Right now, beneath one of the most photographed islands on Earth, something is moving. A reservoir of molten rock, the volume of 200,000 Olympic swimming pools, has forced its way through the crust in pulsing, violent sheets, and the ground above has not stopped shaking. In early 2025, more than 25,000 earthquakes rattled Santorini and its neighboring islands in just 8 weeks. 11,000 people fled, schools closed, a state of emergency gripped the Aegean. But the seismic storm was only a symptom. What is really happening beneath this ancient caldera? Why are two volcanoes now breathing as one? And if the magma keeps rising, what could come next? Santorini is not a typical island. It is the shattered rim of a volcanic crater, a crescent of white-walled villages perched on cliffs that plunge 300 meters into a flooded abyss. The caldera stretches roughly 12 by 7 kilometers, its basin filled by the Aegean Sea, its center crowned by two dark, smoldering islets called Nea Kameni and Pelea Kameni. Tourists arrive by the millions each year to watch the sunset paint the cliffs amber and gold. Fewer than 20,000 people live here year-round, but during peak season, an estimated 2 million visitors crowd the narrow lanes, fill the infinity pools, and line the caldera rim without knowing what sleeps beneath the water below. This island exists because of destruction. Its beauty is a scar. Roughly 3,600 years ago, the volcano that once stood here tore itself apart in one of the largest eruptions in human history. The Minoan eruption, rated a 7 on the Volcanic Explosivity Index, ejected an estimated 28 to 41 cubic kilometers of dense rock-equivalent material, with some researchers proposing total tephra volumes as high as 60 cubic kilometers when marine deposits are included. The explosion sent a column of ash 35 to 40 kilometers into the sky and blanketed the eastern Mediterranean in debris. The resulting caldera collapse swallowed the center of the island, leaving only a ring of shattered rock behind. That blast contributed to the decline of the Minoan civilization on nearby Crete, unleashing tsunamis that smashed coastal settlements and disrupting agricultural lands across the Aegean. The ruins of the ancient town of Akrotiri remain frozen in time beneath the modern landscape. But the Minoan eruption was not the end, it was the beginning of a cycle. Since that cataclysm, Santorini has erupted repeatedly. Lava domes rose from the caldera floor, building the Kameni Islands through a series of eruptions stretching from 197 CE to 1950 CE. A major explosive event in 726 CE produced approximately 3 cubic kilometers of pumice and ash, far larger than previously assumed. Research from the International Ocean Discovery Program has revealed that the volcano's post-collapse phases can be more hazardous than scientists once believed, with the 726 event now understood to have been of the same order of magnitude as the 2022 Hunga Tonga blast. And then there is the other volcano. Just 7 kilometers to the northeast, hidden beneath roughly 500 meters of sea, lies Columbo. What happened there in 1650 changed the way scientists understand this region forever.
Columbo is a submarine giant. Its crater stretches approximately 2.5 kilometers across, sitting on the sea floor in a zone of intense hydrothermal activity, where vents blast superheated fluids at temperatures up to 220 degrees Celsius. In September of 1650, the volcano breached the sea surface. For weeks beforehand, inhabitants of the surrounding islands felt earthquakes, noticed the sea changing color, and heard subterranean roaring. When the climactic eruption came on September 29, it sent pyroclastic flows skimming across the open water to the shores of Santorini and released clouds of toxic gas, likely rich in hydrogen sulfide, that killed around 70 people and many animals. A tsunami followed, smashing into the eastern coast of Thera, with waves reaching up to 20 meters in height, flooding approximately 2 square kilometers of coastal land at Kamari and Parisa. The inundation eroded overlying sediment, exposing Hellenistic and Byzantine ruins that had been buried beneath the sand. For a brief time, a small island of white pumice rose from the waves before the sea reclaimed it. But Columbo did not go quiet. It only went unseen. In 2022, scientists using a technique called full waveform inversion discovered a previously undetected magma chamber sitting approximately 2 to 4 kilometers beneath the sea floor under Columbo. The study, published in the journal Geochemistry, Geophysics, Geosystems, found that the chamber has been growing at a rate of roughly 4 million cubic meters per year since the 1650 eruption, now holding an estimated 1.4 cubic kilometers of molten rock. The researchers warned that if this accumulation continues, Columbo could reach the eruptive volume threshold of its last blast, around 2 cubic kilometers, within the next 150 years. The characteristics of the system point toward a highly explosive future eruption. Scientists have compared Columbo's potential to the 2022 Hunga Tonga blast in the South Pacific, though they note the eruption would likely be smaller, perhaps a VEI-4 compared to Hunga Tonga's VEI-5. Columbo's shallow depth of approximately 500 meters could still amplify its explosivity far beyond what a deeper submarine volcano would produce, as interaction between magma and seawater intensifies fragmentation. And that discovery was only the beginning of the alarm. Starting in mid-2024, instruments detected subtle uplift across Santorini's Caldera floor, with satellite INSAR measurements showing deformation consistent with renewed magmatic inflation. Increased emissions of carbon dioxide from the volcanic vents suggested fresh magma was quietly filling the shallow reservoir beneath the island itself. This went largely unnoticed outside the scientific community. Then, on January 27, 2025, everything changed. A swarm of earthquakes erupted between Santorini and the island of Amorgos. Within days, the tremors grew in magnitude and frequency. By early February, over 1,200 quakes had been recorded in just 2 weeks, with 129 exceeding magnitude 4 and the strongest reaching 5.2. Most struck at depths between 10 and 15 kilometers along a northeast-southwest trending cluster near the uninhabited islet of Anidros. On February 5th, Greece declared a state of emergency. 11,000 people evacuated Santorini by ferry and air, approximately 7,000 by sea and 4,000 by plane. Schools closed across 4 islands. Emergency crews deployed rescue teams, search dogs, and psychosocial support units. Hotels were ordered to drain their swimming pools to protect structures from seismic stress. The old port was sealed off due to tsunami risk. For weeks, the islands held their breath.
No one could say whether the quake signaled tectonic movement along a fault or the rise of magma toward the surface. The worst-case scenarios invoked the ghost of 1956, when the largest earthquake to strike Greece in the 20th century, magnitude 7.7 on the moment magnitude scale, ripped through this exact zone and triggered a tsunami with waves reaching up to 25 to 30 meters along the southern coast of Amorgos. That earthquake demolished 529 homes, severely damaged nearly 1,500 more, and killed 53 people. Eyewitness reports describe the sea initially retreating from coastal harbors in the Cyclades before the water surged back with devastating force, a characteristic behavior of landslide-generated tsunamis. The faults that ruptured in 1956 sit directly alongside the zone activated in 2025. But the 2025 crisis revealed something the 1956 disaster could not. Using machine learning algorithms trained on decades of seismic data, an international team detected and precisely located over 25,000 individual earthquakes across the 8-week swarm. The resolution was unprecedented. Published in the journal Science, their analysis showed that sheets of magma had sliced horizontally through the crust in waves and pulses at depths greater than 10 kilometers, spreading across an area of 20 kilometers. The intrusions expanded outward from a deep reservoir that, based on the stress patterns mapped by the research team, links both the Santorini caldera and the Kolumbo submarine volcano. 2 volcanoes, once thought to operate independently, appear connected through a shared magmatic plumbing system. The magma pumped through newly opened fractures like blood through arteries, each pulse triggering cascading earthquakes across the surrounding rock. The 2 volcanoes are breathing together.
Critically, the intruded magma did not have enough pressure or buoyancy to reach the surface. There was no eruption, but the volume of magma involved was staggering, enough to fill 200,000 Olympic-sized swimming pools. The energy discharged underground reshaped the stress field across the entire region, leaving scientists uncertain about what the crust will do next. Here, the technical picture deserves a closer look. A separate study detected a seismic tremor on February 14, 2025, with characteristics distinct from ordinary earthquakes. This low-frequency signal, widely observed across regional seismic stations, pointed toward deep fluid dynamics, the slow movement of magma or gas through conduits connecting both volcanic systems. Researchers identified two families of tremor, one caused by densely overlapping earthquake sequences and another linked to deeper magma-driven processes. The distinction matters because purely tectonic swarms do not typically produce sustained tremor of this kind. Its presence strongly suggests active magmatic involvement, even though the intrusion stalled before reaching the surface. The implications shook the scientific community. On the Caldera Rim in the village of Oya, a hotel owner who has lived above the crater for decades barely slept during the weeks of the swarm. Bookings collapsed. Guests called in panic, demanding refunds. The walls of her century-old building trembled with each aftershock, and fine dust fell from the ceiling onto freshly made beds. She watched from her terrace as ferries pulled away from the port, loaded with neighbors who might not return. She told a local reporter the only words that felt honest. "The ground shakes and you realize the beauty you built your life on was never yours to keep." At night, the village was nearly silent. The famous sunset still burned across the caldera, but the cliffs beneath glowed with a different kind of meaning.
Scientists now face a set of scenarios that range from uneasy quiet to catastrophe. In the first scenario, seismicity returns to background levels, the magma stalls, and the system stabilizes for years or decades. This is possible and has happened before, notably after a similar period of unrest in 2011-2012, when the magma chamber swelled by 10 to 20 million cubic meters without producing an eruption. In the second, the intrusion continues at a slow burn. Years of recurring earthquake swarms, gradual deformation, and increased gas emissions erode infrastructure and drive away residents and tourists in a slow economic bleed. The third scenario is the one no one wants to name. If the magma chamber beneath Columbo reaches critical pressure, or if a new intrusion connects the deep reservoir to the surface through both volcanic systems simultaneously, the result could be a dual eruption. A blast from Columbo could send an eruption column high enough to disrupt regional air travel, while pyroclastic flows and tsunamis could radiate across the Aegean. Modeling suggests a tsunami from Columbo could reach Santorini's northeast coast in as little as 2 to 3 minutes, with the southeastern coast exposed within 8 to 10 minutes. While the Mediterranean does operate a tsunami early warning system through UNESCO's NEA-MTWS network, experts have raised concerns about whether the system can provide adequate warning for events generated this close to populated coastlines. This worst-case interpretation must be understood in context. No scientist is predicting an imminent eruption. The magma intruded in 2025 lacked the pressure to break through, but the system has demonstrated it can mobilize enormous volumes of molten rock rapidly and without warning. And the shared plumbing between Santorini and Columbo means stress changes in one volcano could propagate to the other. The disagreements among experts remain real. During the crisis, some seismologists argued the swarm was purely tectonic, a fault slip that had nothing to do with magma. Others insisted the volcanic signal was unmistakable. The science publication in late 2025 settled much of the debate by imaging the dike intrusion directly, but questions remain about whether the next episode will follow the same pattern or escalate. Monitoring has intensified. The Santorini project, an international effort to build a permanent seafloor observatory around Columbo, has been deploying instruments capable of measuring changes in pressure, temperature, and seismicity in real time. ROV missions have surveyed the fault scarps activated in 2025. Satellite radar tracks millimeter-scale deformation of the caldera surface.
Based on ongoing monitoring data, seismic activity in the region continued at low levels through mid-2025, with occasional small clusters detected beneath the caldera along the same deep volcanic pathway that has fed eruptions for hundreds of thousands of years. The Mediterranean hides more than one giant. In the Tyrrhenian Sea, the Marsilli seamount rises roughly 3,000 meters from the ocean floor, making it the largest submarine volcano in the Mediterranean. Its hydrothermally weakened flanks carry a risk of catastrophic collapse. Modeling by the tsunami research team of the University of Bologna shows that a medium to large flank failure could generate tsunamis reaching the Aegean Islands in around 10 minutes and the coasts of Calabria and Sicily in 20. The volcano has produced eruptions in historical times, but is only sparsely monitored. Santorini is not an isolated threat. It sits within a web of active volcanic and tectonic systems that stretch from the Hellenic Arc to the Italian peninsula, all of them linked by the slow, relentless subduction of the African plate beneath Europe. The paradise that draws millions each year was born from violence. The caldera's whitewashed beauty is the face of a wound 3,600 years old. Beneath the sunset terraces and the blue-domed churches, the magma reservoir is refilling. The crust above it shifts and cracks with each new intrusion. The connection between Santorini and Columbo has been confirmed, and the system has shown it can mobilize enough molten rock to reshape the seafloor in a matter of weeks. Scientists know the volcano is recharging. They know the two systems share a deep source. They know the faults in this region can produce earthquakes and tsunamis of devastating scale. What they do not know is whether the next swarm will end as quietly as the last, or whether the magma will find its way to the surface. The silence over Santorini is not peace, it is pressure, building in the dark, waiting for a fracture thin enough to break. Somewhere beneath the Aegean, the monitoring instruments are still recording, the numbers are still climbing, and the next signal has not yet arrived.